Good morning, Sam.
Good afternoon, Michael.
Nice and simple question for you today. If you want to set up the data infrastructure for a country, how would you start?
You know what? I would start with the experts at Hewlett Packard Enterprise and get their thoughts on how I should go about this totally easy and simple task.
Well, I think I would start with what's the need? What's the requirement? That's where I would start. But anyway, today we are chatting to somebody who is currently trying to build an enormous data center designed to work across not just countries, but multiple continents. How cool is that?
It is ice cold.
I'm Michael Bird.
And I'm Sam Jarrell.
And welcome to Technology Now from HPE. There are over 10,000 data centers around the world, and of those, 45% of them are based in the US alone, according to research carried out by Cargason.
Wow, that is a lot of them. But how does the number of data centers relate to their size?
Well, that is the big question, particularly in 2026, right? The biggest data center in the world is designed to hold over 1 million servers, which is a staggering quantity of not just information, but of course, staggering compute power. And we will, of course, link to all of these stats in the show notes.
And would you say it's reasonable to say that data centers are driving the current industrial revolution?
I think it would be very fair to say that, Sam. I think this boom that we're seeing in the world of AI would not be possible were it not for data centers. Now, to talk more about how different countries are harnessing the power of data centers and AI, I chatted to Talal al Kaissi, the interim CEO of the company Core42.
But before we talk to Talal, I want to take a look back at the humbler origins of the modern-day data center. It's time for Technology Ven. Michael, it's my turn to ask you something. Do you know when the first data center was built? And for bonus points, where was it created?
Okay, East Coast in the US, 1968. 72.
Fair guesses, fair guesses. We're going to throw it actually all the way back to Pennsylvania in the mid-1940s. And the completion of the Electronic Numerical Integrator and Computer, or as I like to call it, ENIAC for short. ENIAC used just 150 kilowatts of electricity to run almost 18,000 vacuum tubes and 6,000 switches. And its external memory was, of course, punch cards.
That uses as much electricity as my car can use to charge itself at one of those rapid chargers. That's not a lot of electricity for quite a large space.
It just goes to show how far we've come, right?
Yeah.
It needs an entire room to house it, a full 1,800 square feet of space. That's about 167 square meters for you, Michael. The ENIAC is generally recognized as the world's first data center. It would have looked hugely different to the ones we know today. ENIAC and its direct descendants were so big that the server room only held servers for a single system, along with the specialized power and cooling systems, which needed to go with it. They were big and expensive and not accessible to anyone outside of universities, governments, or a few large corporations. In fact, it would take another 40 years or so for the general-purpose data centers to come onto the scene. With the advent of microchips and the increase in density of processing power, these original data centers transformed from glorified server rooms into vital infrastructure as demand exploded. The internet erupted onto the scene, and cloud computing was then adopted. Today, the world's biggest data center by physical size is in China. It requires 150 megawatts of power. That's 1,000 times what ENIAC needed. And it's 10.7 million square feet.
Can't believe we're now measuring data centers at that sort of scale. It's absolutely mind-boggling. And I think it's going to get more impressive when we hear from our guest for this week. Talal al Kaissi is the interim CEO of Core42, who are in the process of creating a 5 gigawatt data center. But before we talked about the data center, I wanted to know exactly how he got to where he is today.
So on my day job, I focus on the digital infrastructure business. I'm the interim CEO at Core42. And my night job, which has been really the brunt of my focus for the past 2 years, it's on the group level. I work on global affairs. So I try to help with everything from getting our industry partners aligned, figuring out the advocacy engine that we need to have on government levels across the world, particularly in the US because of our US partners, and because this is such a consequential technology. So in my 9 years at the UAE Embassy in Washington, I understood how that mechanism works to be able to inspire confidence in deploying this type of infrastructure that's so consequential that can have the security envelope required. So getting the export licenses for these types of chips that are material, especially when you have 5 gigawatt cluster that you need to fill, is something that was predominantly the use of my last 2 years in terms of travel and air miles.
Okay, so can you tell us who G42 is, where G42 came from? Just give me the story.
Yeah. So, G42 essentially is a collection of technology companies, and we touch on a significant portion of the AI value chain, everything from the physical infrastructure, the cloud environments we have, be it the private cloud that's disconnected for the requirement of high autarky and sovereignty in terms of being disconnected. Then you have what we call the sovereign public cloud, to have the majority of public sector and regulated industries be able to consume public cloud, but also have a sovereign control envelope that ensures that they protect the imperative of data. And then the AI cloud, and that's something we're working on with HPE and others as well, in deploying the AI infrastructure that's used to underpin what we refer to as the intelligence grid, a global network of interconnected AI data centers that can help underpin the enablement of AI native societies. And then you have operating businesses in healthcare and space, Presight, big data analytics and business intelligence, Analog on robotics, CPX and cybersecurity, and Inception that's doing a lot of applied AI research.
Does G42 tie into the UAE's vision for AI? And how does that compare to, say, the US or the way that the EU approach it?
It very much ties into it. I think we are the provider of AI solutions and infrastructure that help underpin what we call AI native societies. And if you look at some of the things that have been announced recently in the UAE, in Abu Dhabi in particular, there's an objective by 2027 by the Crown Prince to make it the first AI native government globally. And so we're really leaning in hard on that. So I think we're a key part of that enablement to ensure that we can plug into intelligence the same way you plug into electricity and gain it as a utility.
So as part of the UAE's $1.4 trillion investment in the US, I believe there are plans for a 5 gigawatt data center. Can you just tell us a bit more about that?
Yeah, sure. So when President Trump visited in May of 2025, we announced the establishment of a joint project with our U.S. partners that's going to have 5 gigawatts of energy that's dedicated to the manufacturing of intelligence. And this is something that's quite unheard of and have to have not just the political will and the economic wherewithal to do something like that, but it all comes down to energy as well. And that's where we've seen, even in our deployments in Europe and in the U.S., that's been the critical bottleneck, in my view, and the limiting factor. So when you have 6 gigawatts of energy that are currently online, then you have the ability to, and the responsibility really, to begin to not manufacture intelligence just for domestic consumption in the UAE. We're only a country of 10 million. So the quadrillions of tokens that are going to be produced, a lot of that's going to be exportable. So we become this real interesting inferencing supernode for the big hyperscalers and model developers to use for the propagation in a responsible way of intelligence to roughly half the world's population in a 3,200 kilometer radius, sub 60 milliseconds with high bandwidth connectivity and low latency. So that's where we feel the responsibility to do that. Now, the 1.4 trillion is obviously investments into the US over a period of 10 years. And that's where we're doubling and tripling down on our investment in not just digital infrastructure, but it goes across the board, across multiple different industries as well.
And so the 5 gigawatt data center will be located in the UAE?
Yeah, it's in Abu Dhabi. It's going to be not just the AI data centers, but it's going to be an ecosystem. There will be joint research and development. There will be other types of facilities, even sub-assembly. So it's broader than just the AI data center component, but it's massive. We're talking 10 square miles. It's quite a sizable commitment by not just the government, but the companies that are involved.
Yeah, I want to ask you about that in a second. But before I do, what is G42's role in this project?
So in that value chain that I mentioned, there are a couple of components that are quite critical to that type of a build-out. Obviously, the physical infrastructure in the data centers. Then you have, in many occasions, Core42 being the operator and partner of choice to some of the model developers so that we could deploy the infrastructure. We buy the GPUs like we're doing with HPE right now for the first batch and operate that on behalf of either our AI cloud or others' AI cloud. And then up the stack, obviously, in terms of us developing our own specialized language models, we have universities that are doing reasoning models, biology models, world models, and all these things are going to become part of what we're able to enable.
Okay, so how on earth do you build a 5 gigawatt AI campus I mean, where do you even start?
So the AI data center component of it is interesting. If you look at it as layers of a cake, right? You've got the connectivity infrastructure, then you've got the data center shell and core, then you've got the chips, you've got the liquid cooling, the network fabric inside. And if you add all that together on a per gigawatt level, about a $50 billion capex. Predominantly today's world, 70 to 80% of that are the chips, but that will continue to go down and will eventually converge with the price of electricity. But if you think of what's needed globally to diffuse AI in a way that will provide equitable access to intelligence globally, you need at least anywhere between 300 and 500 gigawatts of AI data center in different locations across the world. And so we are also, from a capital standpoint, pooling and convening capital allocators and others to help with the capital deployment for this global AI infrastructure build out.
Energy capacity is always a big issue when it comes to AI data centers. How do you see this campus being powered?
So the good thing about what we have today on the grid is a significant percentage is already powered by nuclear. So we've got the 4 reactors that we've built over the past 10 years that are online today. And then there's also solar. We do have one of the largest solar facilities, photovoltaic, that is going to have around the clock baseload of 1.2 gigawatts of energy.
Wow.
When you couple it with battery storage, that's about 5 gigawatts of photovoltaic and 19 gigawatt hours of battery. So that's a very unique situation. So the whole 5 gigawatt campus will be powered by energy that we're bringing in from the grid.
So G42 has an ambition to build an intelligence grid relying on a network of AI-ready data centers. Can you just sort of describe what that practically looks like and who do you see using it?
You need to have these different nodes in different parts of the world to ensure that there's low latency, high bandwidth connectivity that these nodes can serve. And so that's the concept of a grid. But what's more important is if you think back to electricity, today we have 770 million people without access to electricity. We cannot afford the same thing to happen with intelligence. And we really very much view intelligence in a way that's analogous to electricity, that people should be able to plug in and access intelligence as a utility. And to be able to do that effectively and really not have a digital divide with all the potential socioeconomic ramifications that would have between the global north and the global south, you need to be able to situate that grid in a way that can serve places that are not going to have the ability where it's too prohibitive to build out data centers. And that's where we've come up with also the concept that we announced, which is a digital embassy concept, where we can, through G2G agreements, create the political air cover and government-to-government commitments in terms of preserving sovereignty and serving some of these countries out of the UAE. You don't need a substation analogy in data centers in every country. You can actually serve these things remotely and avoid that digital divide. So that's kind of why the intelligence grid is important.
So the concept is they don't have to build out their own data centers in their own countries. Actually, the data center in Abu Dhabi, you can sort of isolate part of that and say this is part of this sovereign nation.
Yes, or provide them a virtual sovereign service with the right sovereign controls, technical and policy-based, that could provide them a similar service to what we provide to our government in the UAE. Yeah. So what we've tried and tested in the UAE that's been compliant from a regulatory standpoint, we can then convey in a way with the same tool set.
So sovereignty is probably something you talk about quite a lot.
Sovereignty is a very nuanced term. It's more than just data residency that people care about. How you protect the data from extraterritorial jurisdictional control that countries can bestow on companies that come from those countries. That's where I think we have to get creative on a technical and policy level, because it wouldn't be convenient to have your genomics data just sitting unchecked on a public cloud susceptible to that. And so we've built and designed tools to create those trusted compute environments and to enable the public sector and regulated industries to benefit from the value of the deployments that we have.
From your perspective, what does sovereignty mean to you when you think about it?
It means a level of control, and every country wants to have a certain level of control at the very basic level of the data that they're providing, especially if it's sensitive data. So there are different classifications of data. Top secret data definitely requires an air-gap disconnected cloud setting, and you have that. But you want to minimize that footprint because it's inherently limited and it's not as feature-rich or customizable or scalable even by definition to what public clouds can provide. But a public cloud is the other extreme where it's completely unchecked. So you find the sweet spot in between through these technical and policy controls to enable the use of that feature-rich environment in a compliant way so that regulators and customers in financial services, healthcare, and energy can benefit from that type of an infrastructure.
So what you're saying is that it's not like, here you go, here's a sovereign cloud. It's like, okay, well, what actually are you using it for? If it's healthcare data, then you probably need this.
And there's trade-offs, right? In certain situations, you want multiple layers of sovereignty. You want operational sovereignty. sovereignty, where you have your own people that are operating the environment. You want financial sovereignty. Nobody else is paying for it. So you're not subject to someone cutting something off, right? And depending on the use case, depending on the workload, you need to have a more versatile approach and offering that allows to mix and match depending on the imperatives that a country has, or a sector or a company or an enterprise has around data, to ensure their compliance and ensure also IP protection.
Talal, it's been a fascinating conversation. Thank you so much for joining us on Technology Now. Really appreciate your time.
My pleasure.
Goodness. Well, I still can't get over the number he tossed out. 5 gigawatts of AI data center capacity, a single space in Abu Dhabi.
And 10 square miles as well. That's massive, isn't it? What I found interesting was how they were powering it. I love a chat about PV and batteries. So he said 1.2 gigawatts of PV.
I thought, part of it, the way he broke it down was kind of interesting. Like, if you look at like a gigawatt of an AI data center, you're talking about roughly, he said, 50 billion of CapEx.
Yeah.
And so right now, about 70 to 80% of that is the chips. And then over time, that starts to converge with the cost of electricity. But if you also have those like nuclear reactors powering things, like, are you able to still then further cut the cost?
I think the economics are sort of slightly mind-blowing. He talked about the intelligence grid and how intelligence should be a utility. We live in a world where if you have access to the internet, then you have access to lots of websites. You sort of have access to information. And actually, we want to democratize that.
770 million people don't have access to electricity. So I feel like in order to even have access to the intelligence, we'll have to bridge that divide at some point.
So I think he talked about serving countries remotely and then building this sort of virtual sovereign controls. So I think I likened it in the interview to partitioning off part of that data center. But I like, when I asked him about sovereignty, he gave the same answer to an interview that we did, where he basically said, okay, but what do you actually mean by sovereignty? And he talked about, there are loads of different things you could think about. Operational sovereignty, where you have your own people, and financial sovereignty, which I thought was really interesting.
Yeah, when we've been talking to more technical folks, it tends to go back to the sense of control. And I think that this opens up a very interesting discussion around like whether or not governments will still be comfortable renting essentially sovereign AI capable infrastructure. It sounds like a great concept. I just wonder if they will still be reticent since the data wouldn't physically live where they are.
What he sort of alluded to was the fact that it's not, your data is either sovereign or not. There's a spectrum. You could have everything air gapped. For example, information that your citizens want to access about, I don't know, car registration details. Like, if that's air gapped and super secure, then that's going to be really hard to access. So, but equally, you don't want everything on the public cloud, because that's the other extreme. You could maybe see a scenario where a nation would say, well, this information, whilst it's, it's important information, actually, we're happy to put that in that sort of environment.
Yeah, it all comes down to trust, right? If people don't trust how their data is handled, none of this, no matter how big or powerful the data center is, will deliver on the impact.
Now, Sam, I don't know if you remember, last summer, HPE went through a rebrand.
How could I forget?
Now, because brands and names are important, I wanted to know where Core 42 got their name. Can you guess what it actually means? It's a pretty nerdy answer.
I'm going to guess it has something to do with like ports on like something in a data center, right? Like,
I don't want to give it too much away. Okay, let's let Talal give the answer.
The 42 actually comes from The Hitchhiker's Guide to the Galaxy as the answer to life, the universe, and everything.
Got it.
So that's where we draw our inspiration. Not many people know that. Some people thought it was 42 companies. That's what actually got me sold into getting into G42. I had left the embassy at that time, and I was in the space industry. We were working our Mars mission, and at that point, I met with our group CEO, Peng, and he mentioned 2 things. One was the 42. The other was that we are having AI augment human ingenuity to solve the biggest problems that we have on Earth, all the way inner space, molecular level, like the genomics program we have, all the way to outer space, which is measured in 10 to the power of 12 in light years, and answer life's biggest questions.
So 42 matches pretty well, actually.
Indeed, it does.
Okay, that brings us to the end of Technology Now for this week. Thank you to our guest, Talal al Kaissi, and of course to our listeners. Thank you so much for joining us.
Yes, and if you've enjoyed this episode, please do let us know. Rate and review us wherever you listen to episodes. And if you want to get in contact with us, send us an email to technologynow@hp.com, subject line data center. And don't forget to subscribe so you can listen first every week. I always judge how successful my subject lines are is whether I can make you laugh or not. And you gave a very stoic smile, so Maybe I'll try better next time. Anyway, Technology Now is hosted by Sam, Jarrell, and myself, Michael Bird. This episode was produced by Harry Lamput and Izzy Clark, with production support from Alicia Kempson-Taylor, Becky Bird, Alyssa Mitri, and Janessa Ayosh. Our theme music was composed by Greg Hooper.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, and Jacqueline Green. And our social media designers are Alejandra Garcia and Ambar Maldonado. Technology Now is a Fresh Air production for Hewlett Packard Enterprise. We'll see you at the same time, the same place next week. Cheers. Bye, y'all.